The Constitution of India. Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. So today we are going to continue with the 6th chapter with nomenclature of compounds, organic compounds. In that last class we were seeing about alkane and alkene, that is saturated hydrocarbon. In alkane we know the molecular formula is CnH2n plus 2. That is, if N is the number of carbon atoms, the number of hydrogen atoms will be twice the number of carbon atoms plus 2 added to it. You understand, children? It will be C2H6. Number of carbon atoms is 2. So 2 into 2, 4 plus 2, 6 will be the number of hydrogen atoms. And when you are writing alkanes, that is saturated hydrocarbon, you should make sure that there are only single bonds around the carbon atoms. That is, the bond between carbon and carbon or the bond between carbon and hydrogen are completely single. So when you have only single bonds, you call that type of hydrocarbons as saturated hydrocarbons. What do you call them as? Saturated hydrocarbons, or you also call them as alkanes. You call them as alkanes. We were also seeing about alkene. I told you when there is ANE, it is single bond. When you have ENE, alkene, when you have ENE, it is alkene, which is nothing but double bond. That is, when you have a double bond between any two carbons, you call them as unsaturated hydrocarbons. Unsaturated hydrocarbons are of two types. One is a double bonded compound, the other one is a triple bonded compounds. So last class we were seeing about double bonded carbon compounds, where you have a double bond between two carbon atoms. If you see, children, there are 3 carbon atoms and you have a double bond here between the second carbon and the third carbon, and when I am writing the open chain structure, I am writing like this, that is, the double bond is between second and the third carbon. You can decide where you want to put. Now I can put it here also, right? So I can put between these 2 carbon atoms also, it means the same. So these type of double bonded carbon compounds, you call them as unsaturated hydrocarbons or alkenes, where alkene represents double bond. Now there is something which we call it as alkyne. In alkyne we have only triple bonded carbon atoms. So now we will learn about triple bonded carbon atoms, where the triple bond is present between 2 carbon atoms. Okay, now we are going to see about alkynes, which is the next type of hydrocarbon. We call this also as unsaturated hydrocarbon. See, if you remember, children, for alkane it was CnH2n plus 2, and for alkene it is CnH2n. That is, if N is the number of carbon atoms, twice the number of carbon atoms will be hydrogen atoms. But when you come to alkyne, where you have ine, there are triple bonds between the 2 carbon atoms. If you find a triple bond between any 2 carbon atoms, you categorize them as alkyne, which is also an unsaturated hydrocarbon. So what will be the molecular formula? CnH2n H2N minus 2. That is, if n carbon atoms are present, listen, if n carbon atoms are present, number of hydrogen atoms will be twice the number of carbon atoms minus 2. Example, if you have 2 carbon atoms, hydrogen will be 2 into 2 minus 2, where 2 into 2 is 4, minus 2 will be 2, that is C2H2. How do you represent it? You put 2 carbon atoms and we know the valency of carbon is 4. So, around the carbon there should be 4 bond. So, this is my first carbon, my second carbon. So, I have 1, 2, 3, the fourth one is hydrogen. Similarly, the second carbon 1, 2, 3, fourth will be hydrogen. So, it can be represented in the condensed way CH triple bond CH, which is C2H2. Now, if I am going to see where I have 3 carbon atoms, so I first put the carbon atoms, and when I am putting the triple bond, the first carbon atom has got 1, 2, 3, 4. Valency is satisfied. For the second carbon atom, it is 1, 2, 3, 4. Again valency gets satisfied. The third carbon atom 1, I need 3 more bonds, all the 3 will be satisfied by hydrogen. If you see very carefully children, the second carbon is not having hydrogen. So, you need not worry. Why second carbon is not having hydrogen? If you need to satisfy the valency, then only you need to put hydrogen. Already there are 4 bonds around the second carbon. So, there is no necessary to put the hydrogen atom here. And so, the condensed formula I have written, and here it is C3H4. Now, if you come to the next one with 4 carbon atoms, I have put 4 carbon atoms. The first carbon atom 1, 2, 3, fourth one is hydrogen. Second carbon atom no hydrogen because already 4 bonds are there surrounding the carbon atom. For the third carbon atom there is only 1 bond on the left. So, 2 on the top, 3 on the bottom and the fourth one on the right of the carbon. And similarly for the fourth carbon also 1, 2, 3, 4. And I have written the condensed form and the molecular formula. So, with this you can understand children how the molecules are written, how the structures are written. Now, we will learn about the nomenclature. Nomenclature. What did we saw till now? We were seeing that hydrocarbons are broadly classified as alkanes, alkenes and alkynes, where alkenes and alkynes are unsaturated hydrocarbon, alkanes are saturated hydrocarbons. In alkanes we have only single bond, alkenes we have double bond and alkynes we have triple bond. This is what we have seen till now. Now, how do we name this? There is a method for naming this hydrocarbons or the carbon compounds. You call them as IUPAC name, International Union Pure and Applied Chemistry. So, in that way, what is nomenclature? We have so many organic compounds. So, if to differentiate between any 2 organic compounds, you need to name the compound so that it is easy to identify the compound. The compounds are identified or named using 2 important characteristic features. They are the number of carbon atom present in the compound and the nature of chemical bond present in the compound. When I say nature, it can be single, it can be double, it can be triple. So, 2 things, what are they? Number of carbon atoms and the nature of chemical bond in the compound. Now, if you see, we have a word root. What is word root? With this word root only we can find out the name of the compound. If you have, I told you number of carbon atoms, so it is very important. So, if only 1 carbon atom is present, we use the word root meth. If there are 2 carbon atoms, we use eth. If there are 3 carbon atoms, we use prop. 4, we use but. For 5 carbon atoms, we use pent. For 6, it is hex. For 7, it is hept. 8 oct, 9 non, and for 10 it is dec. So these are the common for whether the compound is saturated or unsaturated, that is whether it is an alkane, alkene or alkyne. But you should be knowing the word root with respect to the number of carbon atoms present in it. IUPAC name for unbranched carbon atoms or unbranched compound. What do you mean by unbranches? We have only a straight chain carbon atom. There are no branches. These are not the branches. These are the condensed forms, right? Let me see. Now here I have one carbon atom surrounded by 4 hydrogen atoms. So I write 1 carbon C. Hydrogen I have 4. So it is CH4. So if it is one carbon atom is present, what is the word root? Meth, right? But for alkanes, I should write word root plus ane. Depending on the number of carbon atoms present, I should select my word root, then I will add the suffix ane to it. Word root plus ane, because these are all single bonded carbon compounds. So when it is CH4, I have only one carbon atom, so it is called meth. Meth plus ane becomes methane. You are able to follow, children? Meth plus ane becomes methane. Now we will take an example where I have 2 carbon atoms. This is my first carbon atom, this is my second carbon atom. So number of carbon atoms I will just write here. So it becomes here C2. Number of carbon atoms are 2. So now hydrogen I need to write. You can count the number of hydrogens. 1, 2, 3, 4, 5, 6. So how many hydrogen atoms are there, children? 6 hydrogen atoms. So it becomes C2H6, and if there are 2 carbon atoms, what is the word root? It is eth. ETH. So I put here ETH, eth, word root plus add ane to it. So it is called as ethane. Because it is all alkanes, only single bond are present. Single bond they are called as alkane. So depending on the number of carbon atoms, we will select the word root and then we will add the suffix ane to it. Now let me come to the next question. Here how many carbon atoms are there? Let us name it. Now we have 1, 2, 3, 4, 5 carbon atoms. We have how many, children? 5 carbon atoms. So how many hydrogen atoms are present? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 hydrogen atoms. So when the number of carbon atoms are 5, what is the word root? It is pent. So it becomes pent plus ane, that is pentane. You are able to get me, children? So depending on the number of carbon atoms, we will select the word root and we will add the suffix ane to it. So this is how we will be doing. So let me just give you 2 more examples so that you can understand it much better. Right. Now let us take an example where we have 1, 2, 3, 4, 5, 6, 7. Now I should fill all my carbons with what? Hydrogen to satisfy the valency. So all these are hydrogens. In exam, don't put lines and leave it. You have to fill it with hydrogen. Okay, children. So now how many carbon atoms are there? 7 carbon atoms. So C 7. How many hydrogen atoms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. C7H16. C7, what is the word root? Hept. So I put here hept and I add the suffix ane to it. So you call it as heptane. You are able to get me, children? Now this is an easy way of naming because you don't have any branches. So this can be also written in condensed form, CH3, CH2. The same thing I am writing here, CH2, 4, 5, 6, 7. I wrote in the condensed form, this is the open chain structure and this is the molecular formula. And what is this? This is the name or IUPAC name of the organic compound. Now this is a simple way because you don't have branches in this. It's a straight chain organic compound. Now imagine if you get branches. If you get branches, you have a method for naming the organic compound. So now we will see how to name the organic compound when you have the branches. Let us now see how to name the hydrocarbons if there are branches. What is a branch? Now the same thing, if I have it continuously 5 carbon atoms, this is a straight chain or unbranched hydrocarbon. But if I have the same 5 carbon atoms where one carbon atom is joined to another carbon atom, we call this as a branch. So this type we call them as branched hydrocarbons. Now how to name these hydrocarbons? If you see children, we have the branches, there are certain names given to those branches. What are those? Like for example, they are called as alkyl radicals. What are they called as? Alkyl radicals. If an alkane, any alkane, if an hydrogen is removed, if it loses an hydrogen, it becomes an alkyl, which is denoted as R. I repeat, an alkane, when it loses a hydrogen, it becomes an alkyl. Now you have CH4, methane, loss of one hydrogen, it becomes CH3. So you call it as methyl radical. Methane becomes methyl with the loss of one hydrogen. And if you see here, this is ethane. You also can write it as CH3, When this loses an hydrogen, it becomes C2H5 or CH2CH3, which is called as ethyl radical. So ethane, when it loses a hydrogen, you call it as ethyl radical. Methane, when it loses a hydrogen, you call it as methyl radical. So these are the radicals which will be acting as branches. Now how to name the branched hydrocarbon? You have certain rules which you need to follow for the nomenclature of branched hydrocarbons. Let us see one by one. The first point is identify the longest chain. So you will be given an organic compound or you will be given a hydrocarbon where the first step is to identify the longest chain is the main chain. When you find the longest chain, that will be considered as the main chain. How do you find the longest chain? You need to count the number of carbon atoms, which is a straight chain, not as branches. You should find the straight chain, or if it comes down, it should see which side you have more number of carbon atoms. That will be considered as a main chain. What's the second one? The second one is, once the longest chain or the main chain is been identified, whatever is connected to the main chain will be called as branches. So once you identify the main chain, you have some other radicals, as I said here, these will be attached to the main chain. So those are called as branches. Now the next step is identify the position of the branch. You should be knowing at which carbon atom this particular branch is connected or bonded. How do you find it? You can find it by numbering the main chain. Once you count the number of carbon atoms, once we get the longest chain, then you should start numbering the chain so that you know the position of the branch. And always remember children, the position of the branch should always get the lowest number. I repeat it again, the lowest number should be the position of the branch. So your numbering should be done in such a way that our position of the branch gets the least numbering. Now let's take an example where we are going to write the IUPAC name of this compound. If you see here, this is the hydrocarbon given to you. So now we will identify how many carbon atoms are there. 1, 2, 3, 4, right? That is my longest chain. Yes, so there are 4 carbon atoms. So number of carbon atoms will be, total how many are there? They are asking in the main chain. Number of carbon atoms in the main chain is 4, right? Now what is the word root if 4 is the number of carbon atoms? It is butane. If number of carbon atoms is 4, you call it as butane. Now what is the suffix? But, word root is but, and what is the suffix? Suffix is ane, because all these are single bonded carbon atoms. Now I should name the alkyl branch. Which is my alkyl branch? This is my main chain. So this will be acting as my branch. So if CH3 is present, you call it as methyl, because one carbon atom, it is methyl. If 2 carbon atoms, it is ethyl. If there are 3 carbon atoms, it is propyl. So here you have only 1 carbon atom. So the name of alkyl branch is methyl. Now the next most important, which is the position of the branch. How do I find the position? I need to number the main chain. Now let's do 2 way of numbering. One is from left to right, the other is from right to left. Let us see in which side the branch position gets the lowest number. So here I put 1, 2, 3, 4, and here I put 1, 2, 3, 4. So when I count from left to right, the position of the branch is 3. But when I count from right to left, the position of the branch becomes 2. So which side is the correct way of numbering? From right to left. So it is not mandatory that you should always count from left to right. You can also count from right to left, but you should make sure that the position of the branch gets the lowest number. So here we got the lowest number as 2. So the position of the branch is 2. Now how do I write the IUPAC name? First, I'll write the position of the branch 2. I put a hyphen. After I write a number, I put a hyphen. Then I write the name of the radical, which is methyl. 2 hyphen methyl. Then I write the word root and suffix, which is butane. So I put 2 methyl butane. That is the IUPAC name of the compound. Now I am going to give you one more compound where we will see how to name the hydrocarbon with the branch. So let us do it together, children. I have here CH3, CH2, CH, CH3, CH2. See, this is the compound given to us, right? What is the first thing we need to do? Identify the number of carbon atoms in the main chain. So it is 1, 2, 3, 4, 5, 6. So the number of carbon atoms is equal to 6. 6 carbon atoms are there. Next is I need to find the word root. If there are 6 carbon atoms, what is the word root? Word root is hex. So I put here hex. So what will be my suffix? I have all the bonds to be single. So it is a saturated hydrocarbon. So they are alkanes. So my word root is ane. Right. Name of the alkyl branch. If this is my main chain, so these are my branches. So name of the alkyl branch, again 1 carbon atom, which is nothing but methyl. Now position of the branch, again comes numbering from left to right and right to left. So shall we do the numbering, children? From left to right it is 1, 2, 3, 4, 5, 6. So when I count from left to right, the position of the branch is actually 3. But when I count from right to left, 1, 2, 3, 4, 5, 6. What is my position? It has become 4. So which is the correct way of numbering here? From left to right. So the position of the branch is 3. How do I write my IUPAC name? First I write the position of the branch 3. I put a hyphen. Then I write the name of the radical, which is methyl. So 3 methyl. I write the word root hex and then the suffix ane. So it becomes 3 methyl hexane. I hope you are able to follow, children. Is there any doubt? So you have in page number 103, 1, 2, 3, 4 questions are there. Try to solve the questions, and in the textbook you can do it, or if you can do it in the notebook, that is much better, because the space constraint is there in the textbook. So copy the same questions in the notebook, in the file, and do it, and then I may ask anybody. Okay. So then we will go to name of the hydrocarbons with more than one branch. We will see how to name the hydrocarbon with more than one branch. So first we were seeing writing the IUPAC name for unbranched hydrocarbon. Next we saw naming the hydrocarbon with branches where there were only one branch present, but here now we are going to see where there are more than one branches present. So if there are more than one branch present, you can use the word di-tri. Maximum there will be only 3 branches where all the branches are with the same alkyl radical. So the numbering should be done in both the ways, where the first branch should be getting the lowest number, that is the lowest number should be given to the first branch. This is the most important thing we should remember when you have multiple branches. So let us do 2-3 examples to understand it better. This is a compound given to us. So let us count the number of carbon atoms first. So you have 1, 2, 3, 4, 5, 6, 7. Number of carbon atoms 7. So we know what is a word root. It is hepta and suffix is ane. So you can write on the side heptane. Number of branches. So if this is going to be my main chain, whatever are attached to the main chain are called as branches. So how many branches I have here? This is my first branch, this is my second branch. So number of branches are 2. Now I am going to do the numbering to find out the position of the first branch from left to right. So when I count from left to right, this is my 1, 2, 3, 4, 5, 6, 7. This is my position of the first branch is getting the number 2 if I count from left to right. When I count from right to left, this is my first branch. So let me see what is the position it is getting. So it is 1, 2, 3, 4, 5, 6, 7. So 4 will be the position of the first branch when I count from right to left. So I did 2 ways of numbering. Now which is the correct method of numbering? As I told you earlier, when we do the numbering, the branches should get the lowest number. Especially when there are 2 branches, the first branch should be getting the lowest position number. So here when I count from left to right, the first branch is getting the number 2, but when I count from right to left, the first branch is getting the number 4. So the correct way of numbering is from left to right. Now how do I write the IUPAC name? We know first we will write the position. So I put here, this is my second carbon having the branch, and my fourth carbon is also having the branch when I count from left to right. So I put here 2, 4. Why I put 2, 4? Because the second carbon and the fourth carbon are having the branches. So 2, 4. How many methyl groups are present here? Name of the branch is methyl. How many methyl groups? 2 methyl groups. So I put 2, 4 dimethyl. What do I put? 2, 4 dimethyl heptane. Understood, children? 2, 4 dimethyl heptane. Because there are 2 methyl groups as branches. Now when you come to the second problem, here 1, 2, 3, 4, 5. Number of carbon atoms 5. Number of branches, this is my main carbon atom. So I have a branch down here, I have a branch on the top. So how many branches? 2 branches. Now position of the first branch from left to right. This is my left, this is my right. If I am going to count, this is my first branch. So 1, 2, 3, 4, 5. So I get the position here 2. Now when I count from right to left, what will be my position? 1, 2, 3, 4, 5. So here also I am getting the position 2. Is there any change in the position of the branches? No, there is no change. When I count from left to right or from right to left, both the side, the first branch is getting the lowest number. So I can take left to right as a number of the hydrocarbons, numbering of the hydrocarbons. So when I count from left to right, second carbon is having the position and the fourth carbon is having the position. So it will be 2, 4 dimethyl. Since it is 5, you will write as pentane. Understood? This is how we need to do it. If there are 3 methyl groups, you put 2, 3, 5 trimethyl. Now what happens if you get the branches at the same carbon atom? For example, I have like this CH3, 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 this is CH. If I get like this, how do I name? I know 1, 2, 3, 4, 5. So 5 carbon atoms is nothing but pentane. How many branches are there? 2 branches are there, right? Now with 2 branches, both are methyl, right? So it is dimethyl. Now if I do the numbering from left to right, 1, 2, 3, 4, 5, fourth position. But when I count from right to left, 1, 2, second carbon is having the branches. But if you see children, the difference between this structure and this structure, in this structure, the branches are present in different carbon atoms. But here, the branches, both the branches are present in the same carbon atom. So I should repeat the position number twice. So how do I do it? I put 2, 2 hyphen dimethyl pentane. So when the branches are present at the same carbon atom, you should be repeating the position number also and write how many are present. Are you able to follow children with this? So we'll stop with this. You can do the rest of the homework that is given. From next class we will learn with the name how to draw the structure. Because here structures are given, we are giving the name for it. Once the IUPAC name is given, how should we draw the structure formula for it? So that we will learn, and then from the next class we will go into alkenes and aromatic compounds. So if you have any doubt, please let me know. This topic can be a little confusing because you are very new to carbon compounds, that is organic chemistry. Learn, practice it daily and make sure that you do it in the file, and all the exercises continue it regularly. If you have any doubt, please do call me children. Thank you so much. Have a great day. Take care. Bye.